There we go. So as I said, while I'm setting up the presentation here, at least I can. Okay, let's start. Thank you for the introduction. Firstly, what this presentation is looking at is some of the changes in the approach that we need to consider when using technology to lower production cost. And I think having heard Thomas's presentation just now, this is particularly relevant as he covers a lot about organizational changes. And certainly I propose a number of changes that are necessary in this approach. So in the last few years, we've seen an explosion of information. And one of the problems is that we need to make sense of that information. The other problem is that we're also bombarded with false news, and it's very difficult to determine what is good information and what is bad information. So what I'm going to cover in this presentation is a change in the way that we need to look at managing our organizations and in the way that we make decisions. I also want to look at the problem of trying to determine what is good data and what is bad data. I also have a section where I propose that there also needs to be a new order for decision making within many of our organizations if we're going to take advantage of the technology. Also, I'll be promoting the case of using existing data and use a very simple analogy to show how using data from existing sensors can give enormous value without actually waiting for the holy grail of the perfect sensor or the perfect piece of information. I'm also going to end up by showing that this is not a new problem and some of the lessons that we've learned over how to approach this type of thing within our organizations. So the first thing that we really need to tackle is this issue of facts and opinions. So I'll go into it in the next slide in a little bit more detail, but it's not always clear what is a fact and what is an opinion. And that's mainly because they often come together. The next thing we need to look at is because we've been literally bombarded by so much information, is we need to develop filters so that we can filter out what is relevant and what is not relevant to us. And the reason why you want to do that is there is a danger that we run around after false information or misinformation, and therefore we spend a lot of effort and we don't get the results. So this is all about making sure that we align and we get the right results. The third aspect is that we need to make connections throughout the plant and check that the information is verifiable. What I mean by this is many things, is individual sensors can be valuable, but tied together, they can add more value, and very often things are self-correcting. So if one sensor shows that a piece of equipment is down, but the motor to that equipment is showing that it's running, is you can often pinpoint where the problem is. So you need to make more and more connections, and we need to be aware of that. So there's two caveats for this. Don't take information for granted, because misleading information looks exactly the same and sometimes better than good information. In fact, I have a simple analogy, a sort of a simple example from UCT when a rumor went around there that all the students would be getting their vaccinations last week. It was complete false news, but it spread much quicker than the real news. We have to be careful about that. Final thing is you need to constantly challenge everything. The same thing with news is very often we trust the channel that the data comes from. And very often those channels are used purposely to mislead us. And in the plant, it can well be that information or calibration of equipment is not consistent, and we can be looking at information and making the wrong decisions. So let's go through a little bit more. I'm not sure whether this works. No, it doesn't. I can't use a highlighter, that's actually not working at the moment. But what I need, this slide is really about this issue of facts and opinions. If you look at a fact, it's very simple. It can be proven to be true or false. And by default, it's unbiased. An opinion is completely different. It's a personal or an organizational view on something that's not yet been validated. And it may or may not be true. The problem in most organizations is facts and opinions come together. And what people do is they use opinions and they pretend it's a fact. So very carefully, we need to separate the two. What does that mean? If you look at the decision making within an organization, and it actually would be better if I could highlight here. So if you just bear with me a second, I'm just going to see whether I can get this aspect to work. No. Okay, sorry, let me get through to the right slide. What happens in many organizations is a lot of decisions are biased towards people in positional power. So very often you get into a room, there's a lot of discussion, the CEO comes in, it goes quiet, and he says something that's taken as fact and people walk out. So we need to change our way that we make decisions, and we need to go more fact-based. We need to understand that positional power has a place, but we need to be careful about that experience. The other thing we need to recognize is that data in itself is got a lot of faults. It can be incomplete, it can be faulty, and it can be incorrectly interpreted. So good data is relatively rare. What you want to do is you want to bring the experience and the data into your first filter. And the first filter is separate opinion from facts, separate good data from bad data, and use experience that's relevant in that moment. Very often, positional power is they do not have the relevant experience or technical experience for decision at that point in time, but they use their position power to push it through. Be careful of that. The other thing is good analysis is necessary because you need to treat the root cause and not the symptoms. So the way to do that is the whole process relies on results. And if we look at this from a continuous point of view that Thomas brought up, is one of the things we have to focus on is the results and challenge ourselves on those results. If the results are positive, you can bring that back into your filters and make your filters more automatic. If the results are negative, you have to challenge what decisions you made, what data you took, what analysis you did, and just simply make it better. So moving on, what I'd like to do is use an everyday analogy, and it will come back, I promise you, to the minerals business at the end of the presentation. But I'm going to take the example of a car. And the reason why I think it's relevant is a car is an expensive piece of capital equipment that most people own. And when you drive it, you're the user and the owner of that vehicle. And if you look, a vehicle like mining equipment has got multiple sensors. So you take in an individual sensor like a fuel gauge. On its own, it's a very useful sensor. So when it gets down to close to empty, it gives you a warning light, you roughly know how far you've got to go, and you know you need to fill up with fuel. Let's take another sensor that's in most modern cars, and that's the GPS. On its own, an extremely valuable tool. It tells you where you're going, it can give you traffic information, and so on. Now, if you add the two together, you can gain much better insights. So if you have a situation where your fuel light comes on and it's roughly got the range, it can pass that to the GPS. If you're on a route somewhere or on some sort of journey, the GPS can plot where the fuel stations are within your route and within the range of your fuel. It can also, without too much effort, add additional useful information like fuel pricing or facilities within the fuel stations, so that you can make a much more informed decision about where you stop to fill up. No new data is being created. You've just put two useful sensors together and you've created a new insight. So if you look at this issue of adding value, what else can you do? And one of the problems is that a car has other multiple sensors. Temperature sensors, oil gauges, service indicators, brake pad indicators, and so on. The issue with it is that you have to change the way that data is organized. Many times data is organized inside an organization to suit a single purpose. So one of the big ones is ERP systems. ERP systems in many organizations basically feed the financial systems. And yet ERP systems have one of the most valuable databases and insights on consumption patterns that organizations own, but it's often not utilized. So let's look at the car. What else is possible? It becomes possible when organizations start to change their data structure to focus on the end user. And as an example of the car example, is how much better would it be that instead of you booking your next service, is the car manufacturer already knew when your car was due for service, gave you a call, said they were coming round with a car, they'd take you to work, they deliver it the next day, and they'd list with you the things that needed to be done based on the sensors that were there. How much more value and how much more convenient is that? And yet no new data has been added. The only thing that's changed is the management process, decision-making process, and the way that we utilize the information has got so much better. Same way we have that in plants. Is one of the problems in plants, there's multiple sensors on multiple pieces of equipment. One of the problems is that we still work in silos. OEMs develop sensors for their own equipment, and they're not integrated into the total plant. You have the same problem. Many control rooms take those sensors, but very rarely do you see a lot of analysis done on the history to see where we could get better at operating that plant. So there's a wealth of information waiting for us to tap to use that technology to lower costs. So let's take a simple example. What I've done here is a little bit difficult without the highlighter, but in the bottom step of this, a typical breakdown happens on a plant where a piece of equipment will start to lower its performance maybe a couple of weeks before it actually breaks down. Sometimes it doesn't even break down. And within that window of time is what will happen is at the end, if you do get a breakdown, you have to then order spare parts. There could be a supply chain issue. And what the 3 steps at the top show is that if you don't have the spare parts on the mine, all of a sudden you could get a massive delay and a massive slowdown in at that line or that production plant simply because logistics fails the organization. And so one of the things that simply monitoring a plant will provide a benefit. The other thing that we need to do is we need to create much better filters that reduce false alarms and define events. And also the next phase of development will be to take bottlenecks. We took a very simple example of a very simple plant of 300 tons an hour, and we looked at what would happen if one of the crushers, say, had a piece of tramp through it, and suddenly that line started to perform by 20 or 30% lower than it should do. What's surprising is if you look at that, the data model showed that it's very close to R1 million a week in loss. So plants often run below optimal performance. So one of the big benefits that we have by using technology to improve productivity is we may not need to increase plant capacity, just get better at using the plants that we already have. There's a huge benefit to be won here. As a final thing is all of these elements are interconnected. You can optimize maintenance, you can take out inventory, you can increase component life, you can of course increase staff utilization. Instead of staff running around doing inspections, if you're monitoring it correctly and you have the correct algorithms, a highly skilled team can be directed to a point where there's a problem and they can be connected to an expert who doesn't even need to be at the mine site. And all of a sudden you're applying the best process and know-how to a problem extremely quickly. So again, utilizing what already exists from a technology point of view can dramatically improve our know-how and improve our performance. One final thing is I wanted to highlight this is not a new problem. And I took a thing that I thought, an example that I thought was particularly relevant post-COVID, and that was when Florence Nightingale started to introduce sanitization in hospitals. And what you can see in the top right-hand side there of that diagram is what is probably not well known is what Florence Nightingale did is she did 3 very smart things. She recognized that she needed to change the way that hospitals will run. But she also recognized the need for good data and good analysis and root cause analysis. And she also recognized that that needed to be presented in a compelling way so that the people at the time who ran the hospitals and determined the decisions were often military officers of and much older generation. That histogram on the top right-hand side is misleading information as it plots the deaths quite correctly over the months that they happened. And if you read the months, it looks like that the deaths are caused by winter. However, Nightingale, together with William Farr, produced this most amazing rose diagram or vector diagram. And what she did is she plotted the deaths before the sanitization intervention, and then she plotted the deaths after the sanitization intervention. So the rose diagram on the right is before intervention, the rose diagram on the left is prior to intervention. It's a dramatic thing. So what the visualization does is you can see with your eyes that that intervention has had a dramatic effect on the problem. And that's why visualizations are so important, and we need to consider them well. One of the areas we've been working at IMS is this visualization below, where we're using AI to proactively predict breakdowns. And what it does is in normal mode, there's a band where all the sensors work. And if you deviate from the band, you'll see that there is actually an increase here in the deviation from the standard line. And basically the steepness of that line and the height of that line gives you an indication of the deviation and the seriousness of the deviation. So again, what that's trying to do is to create a very simple visualization where the operator can get very quick, deep insights which are intuitive, and he can act on them correctly. Overall, what we need to consider when using technology to increase value. Firstly, there's a massive information, and we need to create filters so that we look at the important issues and take the noise out of the system. We also need to look at separating facts from opinions. One of the big areas that we need to change within most of our organizations is that management systems and decision making needs a review. And that again goes very much back to continuous improvement and the idea of culture, is we're entering a data-driven age and no longer a position power age. So very often people in position power will have to start using data much more, and we have to accept that many decisions in the future will be driven by data, not by our positions. We also need to collaborate so much more than we did before, across organizations and through organizations. It's pointless developing technology inside silos. We need to collaborate, and we need to invest in analysis tools to improve our learning and accelerate our learning. Artificial intelligence is going to greatly accelerate our learning tools. But the warning here is that artificial intelligence also creates false positives. And again, if we look at our management systems and our decision-making systems, and we challenge the data correctly, AI will dramatically improve our understanding of how we can make connections. But without the good decision-making and the change in our approach, is you could end up in a road where AI is dictating things that are outside our control. The final word is, again, be beware of bad data. Fake news has become such a big term in the last couple of years, and unfortunately, it looks as compelling and sometimes better than good data. We have to focus on good data. Thank you.